Hi guys, I'm gonna give you a brief overlook into the atmosphere unit. Again, this is just all review, so I'm gonna give you this walkthrough video right now, and then the next link on the PowerPoint is this specific link to the website, so you guys can go through it on your own to gain more information. And then I'll have an activity and a couple other things for you to look at as well. Um, if you take a look here, this is the pretest, just kind of like to help you gauge your own knowledge on how much you know slash remember about the atmosphere unit. So the first thing, well, two or three main things I'm going to talk to you about are the gases, the structure, and then just briefly touch on the greenhouse effect and air pollution. So the permanent gases in the atmosphere are nitrogen and oxygen, and then with varying levels, you have carbon dioxide, methane, ozone, water vapor, and then particulates or aerosols. Both of those are like smaller types of harmful particulates or chemicals that can sometimes be at varying levels in the atmosphere. And we're going to get into more about these not beneficial gases in just a minute. So the atmosphere structure, and I have not a video, a picture for you guys right here if you can see this. So we have our Earth here. The first layer, where there's like the clouds and kind of like where we live, is the troposphere. The next is the stratosphere. So I like this picture because it kind of gives you like, oh, okay, that's kind of the layer that rockets would visit. Mesosphere, and this gives you, I think these are supposed to be like comets and asteroids and meteorites and stuff like that. Above that is the thermosphere, so that's where our satellites are. And then the exosphere is kind of where the more distant planets are located. So troposphere, stratosphere, mesosphere, thermosphere, exosphere. The top three, these three right here, I would probably be most familiar with because less people talk about thermosphere and exosphere. So those are the atmospheric layers. And kind of, tying all of this together is the greenhouse effect. So we remember, hopefully, the greenhouse gases, and I found this nice website by the EPA, or the Environmental Protection Agency. And it's about an overview of greenhouse gases. So this particular diagram right here is from 2017, but so we can probably imagine that levels are potentially a little bit higher, but this is just kind of giving you a rough, percentage or makeup of the atmosphere. So probably, the majority is carbon dioxide because we know carbon dioxide comes from burning fossil fuels as listed over here. Natural gas, oil, chemical reactions, our factories all emit carbon dioxide, so it's a huge part of the greenhouse gas emissions in the atmosphere. Then we have 10% is methane. So methane is emitted also during the production of coal and natural gas and oil, but it can also come from the mass production of livestock and other agricultural practices because of organic waste decay. If you guys remember, I don't know if all of the classes watched the Leonardo DiCaprio film Before the Flood, but methane was discussed in great detail there because so many people eat meat, and so you have to raise that livestock, and the livestock is what produces the methane. So coming back up here, nitrous oxide, about 6%. So that's kind of just emitted during like lesser agricultural industrial activities, treatment of wastewater. So this is really kind of chemical based. And then the last one is fluorinated gases, 3%. So those are CFCs, fluorinated gases. This comes from kind of like air sprays, cleaning reagents, what else? Any stuff that you would think that you would use for cleaning, that's kind of where these are coming from. And so it's only at 3% because it's not like commonly emitted so it's like a lesser greenhouse gas, if that makes any sense. So yeah, those are our top greenhouse gases. And so going back to the main page, I kind of already outlined this, but by talking about the greenhouse gases, but the greenhouse effect and global warming. So these greenhouse gases, they hurt the ozone layer. And so the ozone layer is what is in the, and we'll go back to this right here. It's in the stratosphere mostly. It's in the stratosphere. And so these greenhouse gases, like a greenhouse that houses plants and stuff like that, it gets trapped. And so there's a natural part of the process when the sun heats up the earth and these gases are emitted and they hit the ozone layer. But in higher levels, it breaks down the ozone layer. And so that's very damaging because it lets in the UV radiation, and UV radiation in more direct amounts is very harmful to crops, plants, animals, fish, and it potentially, if it gets to be too high, it could be harmful to humans as well. So, but these, are constantly being emitted from our factories and all these things that we produce. So it's a cyclic thing because, we need these factories, we need these agricultural companies, but it's in turn hurting our atmosphere. So the last thing here, predicting atmospheric composition, I'm not going to delve too much into this yet. We'll probably get back into it in biosphere. But for predicting the composition, we know that the more greenhouse gases there are, the more the ozone layer is depleted. So for predicting, for the most part, if you Google any types of graphs of, atmospheric composition data or, anything like that, you'll see a pretty steady increase in greenhouse gas emission and a pretty steady resulting decrease in ozone. But, and again, we'll get more into this in biosphere. Recently, because of this coronavirus pandemic, there's actually pollution levels around the globe that are decreasing, and atmospheric or satellite pictures are actually showing that the ozone is finally starting to heal. So the holes are getting smaller. So that's, personally, I think that's pretty interesting. And so I'll give you guys more information about that in Biosphere. You can review these questions and then take the self-assessment quiz.